Welcome to the Deep Dive. Today we're going to unpack the history of artificial intelligence.
Ooh, fun.
We've got this fascinating research paper from the University of Washington as our guide.
Okay.
And believe me, this isn't just some like boring list of facts and dates.
Right.
We're talking about like the dreams,
Yeah.
the defining moments, even some juicy behind-the-scenes stories
I like juice.
that'll make this whole thing come alive.
Awesome.
Yeah. So
Excited.
it's a huge field, of course.
It is a massive field.
But today we're all about giving you that foundation,
Yeah.
those key milestones that really set the stage for where AI is today.
For sure.
Like, how did we get here?
Yeah, how do we get here?
Yeah.
And let's start with this idea, like the quest for thinking machines.
Okay.
It seems like humans have always been fascinated with
Yeah,
this idea of creating something in our own image.
totally.
Something that could well think.
Yeah, like replicate our own abilities.
Yeah.
That's fascinating.
It goes back centuries, really, this fascination.
Wow.
But one of the most influential early visions comes from Vannevar Bush.
Oh.
Back in 1945, he wrote this piece called As We May Think, where he imagined a system to basically amplify human knowledge,
Wow.
almost like a precursor to the internet.
So he was already like grappling with this problem of information overload
Exactly.
even back then.
Even back then, way before the internet.
Wow, that's incredible.
Trying to find a way to make sense of it all.
Yeah.
But then a few years later, Alan Turing comes along.
Okay.
This brilliant mathematician.
Yeah.
He really changed the game.
Yeah.
He shifted the entire conversation around AI away from that philosophical question,
Can machines think?
Can machines think?
Yeah.
And towards this testable proposition,
Okay.
the Turing test.
The Turing test. Right. So how does that work?
All right. So imagine you're a judge.
Yeah.
You're having this text-based conversation with two entities.
Okay.
One human,
Uh-huh.
one machine.
Okay.
Your job is to figure out which is which.
Okay.
No voice cues.
Gotcha.
No physical appearance.
Code words.
Just pure conversation, like back and forth.
And so if the machine can fool you,
Yeah.
a discerning judge,
A good judge.
into thinking it's human,
Yeah.
it passes the test.
That's the idea.
Wow.
And even though it sounds simple, the challenge is immense.
Yeah, I can imagine.
The machine needs to understand language learned from the conversation,
Oh.
even generate creative responses.
Yeah.
It's a tall order, even by today's standards. With all our technology,
For sure.
it's still a tough one.
It's fascinating how this seemingly simple test
Yeah.
became such a driving force in AI research.
Right. It set a long-term goal, a destination.
Yeah.
And like any journey, knowing where you want to end up influences every step you take
Yeah, I like that.
along the way.
It gives you a direction.
Exactly.
So how did those early AI researchers,
yeah.
trying to reach this destination?
Yeah.
Where did they start putting these ideas into practice?
Well, one of the earliest battlegrounds was chess,
Okay, yeah.
long seen as this ultimate test of human intellect.
Makes sense to test AI there.
Yeah.
Chess requires strategy planning,
Oh, yeah.
thinking ahead, outsmarting your opponent.
All those things.
It's a mental battle.
It is. So in the 1950s, this mathematician, Claude Shannon,
Okay.
he laid out two main approaches to computer chess.
Okay.
He called them Type A and Type B.
I'm intrigued. What's the difference?
Okay, so Type A, that's all about brute force.
Okay.
Using sheer computing power
Mhm.
to evaluate millions of possible moves
Wow.
and just picking the best one.
So like a supercharged calculator.
Yes, exactly.
Just crunching numbers.
Crunching number.
Not really thinking in the human sense, just
Right.
raw processing power.
Raw power.
Okay, what about type B?
Okay, Type B is different.
Right.
This focuses on strategic intelligence,
Okay.
teaching the computer to understand the game at a deeper level, recognizing patterns almost like human intuition.
So which one won out in those early days?
Well, initially Type B was favored
Okay.
because computers just weren't that powerful back then.
Right.
But as technology advanced, Type A started to dominate.
Interesting.
A classic example is the chess program developed at Northwestern University.
Okay.
It originally used a Type B approach,
Uh-huh.
but switched to Type A
Okay.
and ended up winning a bunch of computer chess championships.
So practicality trumped elegance.
Yeah, I guess you could say that.
Simply throwing more computing power at the problem.
Yeah, more
But it
horsepower.
was more effective
It did.
than trying to like replicate human-like thinking.
Yeah, it's interesting, right?
But does that mean the machine is truly intelligent?
That is a great question.
Yeah.
And it's one that philosophers and AI experts have been debating for decades.
Really?
It gets to the heart of what we even mean by intelligence.
That's true.
What does that word even mean?
And this debate really came to the forefront with IBM's Deep Blue.
Oh, yes, Deep Blue.
The machine that took on Garry Kasparov.
The world chess champion.
That 1997 match.
Oh, yeah.
That was a huge event.
It captivated the world.
Yeah.
Deep Blue, this classic Type A brute force program, shocked everyone by defeating Kasparov.
It was a big deal.
Was.
I remember reading that Deep Blue was evaluating something like 200 million chess positions per second.
200 million per second.
Mind-boggling.
It is mind-boggling.
Compared to the 50 or so moves a human can examine.
Yeah, we're talking different leagues.
It's a completely different scale.
It really showcases the raw power of modern computing.
Yeah, for sure.
But despite Deep Blue's victory, there were mixed feelings.
Really?
Many argued, including Kasparov himself,
Wow.
that the machine wasn't truly understanding the game, just crunching numbers at an unimaginable speed.
So did Deep Blue actually achieve something profound?
Yeah.
Or was it just a clever, albeit powerful algorithm?
That's the debate, and it continues to this day. Even with more advanced AI systems,
Even now?
yeah, it's still a question we're grappling with.
Interesting.
But here's something interesting.
Okay.
Deep Blue wasn't just a symbolic victory for machines.
Okay.
It had a real impact on IBM, the company behind it.
Oh, right.
Yeah.
Their stock price soared
Yeah.
after that win.
They got tons of free publicity.
It was a marketing coup.
It was.
It shows how AI success stories can
See?
be intertwined with business interests.
For sure, for sure.
But while Deep Blue conquered chess,
Yeah.
another ancient game proved much more challenging.
Much more challenging.
Go.
The game with the black and white stones?
Yes.
I've heard it's incredibly complex.
It makes chess look simple.
Really?
It has something like 200 possible moves at each turn,
Wow.
compared to chess's 40.
So the number of possible game variations?
Explodes exponentially.
Wow.
It's massive.
So even the most powerful computers struggle with it.
They do.
Real. To illustrate that, there was this prize called the Ing Prize.
Right.
It offered $1 million
$1 million.
to anyone who could develop a Go program that could beat a strong amateur player.
Wow, did anyone ever win?
No, for years it went unclaimed.
Wow.
Even the best Go programs couldn't compete with a decent human player.
It's humbling
It
to
is.
think about that.
It was a humbling reminder that some challenges require more than just brute force.
Right, so what did AI researchers do?
Well,
Did they give up on Go?
not at all. It
Right.
forced them to explore more sophisticated Type B approaches,
Okay.
like mathematical morphology.
Mathematical morphology, what is that?
It's a way of analyzing shapes and structures.
Okay.
In Go, it helps the computer see patterns and relationships between stones,
Okay.
not just individual positions on the board.
Yeah.
It's like the computer is developing a more holistic understanding of the game.
So instead of crunching every possible move,
Yeah.
they're trying to teach the computer to see the board more like a human player would.
Exactly.
That's fascinating.
It's a fascinating development. And there's still an ongoing debate
Okay.
about whether massive parallelization,
Ah,
a form of brute force, will eventually win out in Go,
okay.
just like it did in chess.
So it's interesting how this tension between brute force and true understanding
Yeah.
keeps coming up.
It does, doesn't it?
It seems like a fundamental question in AI research.
Absolutely. And this tension plays out in other areas of AI research as well,
Right.
particularly in the development of expert systems.
Expert systems.
Okay, tell me more.
All right, so imagine a computer program
Okay.
that captures the expertise of a human expert in a specific field,
Okay.
like medicine, law, or engineering.
Okay.
That's the idea behind expert systems.
Okay.
They were seen as a way to democratize specialized knowledge, making it accessible to anyone with a computer.
So instead of going to a doctor for a diagnosis,
Yeah.
you could consult a computer program.
That was the idea. That sounds pretty futuristic.
It does, right?
Why don't they actually work?
So they typically have three main parts:
Okay.
a knowledge database, an inference engine, and a user interface.
Okay.
The knowledge database is like this vast library of facts and rules
Okay.
gathered from human experts.
Okay, so you're basically downloading
Yeah.
someone's brain into this database.
In a way,
Okay.
the inference engine is this logic machine that processes information from the database,
Okay.
applying the rules to draw conclusions.
Hmm.
And the user interface allows humans to interact with the system.
So you input your problem or question.
Yeah.
The system analyzes the data
Right.
and spits out a solution or recommendation.
That was the idea.
It's like having a virtual expert at your fingertips.
Yeah.
I can imagine there was a lot of hype around them.
Oh, definitely.
Maybe even some fear that they would replace human experts altogether.
There is definitely some of that.
So were they living up to the hype?
While some were achieving remarkable results.
Oh, really? For example, Dendrol could analyze chemical structures.
Wow.
And MemICIN could diagnose bacterial infections.
That's incredible.
They were demonstrating the practical potential of AI.
So things were looking pretty good for the AI industry.
Yeah, there was a lot of optimism.
What happened next?
Well, as we've seen throughout the history of AI, hype and reality don't always align.
Right.
And in the 1970s, the AI industry experienced a major downturn that became known as the AI winter.
The AI winter. That sounds ominous.
It was a period of decreased funding and interest in AI research, a time when the lofty promises of the field collided with the limitations of the technology.
So what caused this AI winter?
Well, it was more of a gradual shift,
Okay.
driven by several factors.
Okay.
One of the biggest was the failure of machine translation to live up to its hype.
Right, those early attempts to create computer programs
Yeah,
that could automatically translate languages.
exactly.
Yeah.
There was a lot of optimism, especially during the Cold War.
The U.S. government hoped to use it to translate Russian documents.
Makes sense.
But it turned out that translating languages is much more complex than anyone initially realized.
I bet those early machine translation systems
Oh, yeah.
produced some interesting results.
Some hilarious results, I'm sure.
Language is full of nuances and cultural contexts,
Yes.
things that are hard to capture in a computer program.
Exactly.
So the failure of machine translation, it was a big blow to the AI industry.
It was.
Led to funding cuts
Yeah,
and a loss of confidence in the field.
it did.
So it was like the canary in the coal mine for the AI winter.
You could say that.
Okay.
Another contributing factor was a report published by the British government in 1973
Okay.
known as the Lighthill Report.
The Lighthill Report. What was so significant about that?
It concluded that AI research had failed to deliver on its promises, and that further investment was unlikely to yield significant results.
Ouch.
It painted a very bleak picture of the field's future.
What were their specific criticisms?
They highlighted the lack of practical applications for AI research,
Oh, well.
the difficulty of scaling up AI systems to handle real-world problems, and the general overhyping of the field's capabilities.
It sounds like a much-needed reality check for the AI industry.
Yeah, a wake-up call that
Yeah.
things weren't as rosy as they seemed.
And it had a significant impact.
It did, particularly in the UK, leading to funding cuts for AI research.
So the AI winter set in.
Yeah.
Funding dried up, research slowed down.
Things got tough.
What happened to all those researchers and companies that had been so enthusiastic about AI?
Well, many had to rebrand their work to secure funding.
Really?
They started using terms like machine learning, informatics, and knowledge-based systems to distance themselves from the now tarnished reputation of AI.
It's like they were trying to sneak AI research in through the back door.
Yeah, exactly.
Avoiding that stigma.
Avoiding the stigma.
Associated with the term AI.
Yeah, it's interesting how that happens.
Yeah.
And it's a trend that continues today.
Wow.
Many AI advancements are marketed under different names
Really?
to avoid the negative associations of the AI winter.
Wow. That's fascinating.
It is, isn't it?
So what about those companies that had sprung up to support AI research?
Right.
The ones building specialized hardware.
Yeah.
Like those LISP machines?
Those LISP machines.
What happened to them?
Many of them went bankrupt during the AI winter.
Wow.
The market for specialized AI hardware dried up as funding dwindled and the PC revolution took off.
So it was a double whammy for the AI industry.
It was.
The technology wasn't living up to the hype, and the economics were no longer favorable.
The money dried up.
It's no wonder the AI winter lasted for almost 2 decades.
It was a tough time for the field.
Yeah.
But it forced researchers to reevaluate their approach, focus on more foundational problems, and that ultimately paved the way for the resurgence of AI.
That we're seeing today.
So even periods of decline can lead to important breakthroughs and new perspectives.
Sometimes you need to step back and reassess in order to move forward in a more meaningful way.
So while the AI winter was gripping the U.S. and Europe, there was another story unfolding across the world.
On the other side of the globe.
A story of ambition, determination, and ultimately a bold gamble.
A big gamble.
That didn't quite pay off.
It didn't quite work out as planned.
You're talking about Japan's fifth-generation computer system project.
That's the one.
Right.
The one that aimed to revolutionize computing.
Yeah.
And usher in an era of intelligent machines.
It's a fascinating case study.
It is.
Often overlooked.
Yeah, people forget about
Of how even the most well-funded,
the best funded,
and ambitious projects
biggest dreams
can fall short of their goals.
They can.
So let's rewind back to the 1980s.
Okay, back in time. Picture this. The U.S. is in the midst of the AI winter. Funding is scarce.
Yeah.
Researchers are struggling.
Trying to keep the lights on.
Meanwhile, on the other side of the world,
Yeah.
Japan is making a bold move.
A bold move.
They're not just dipping their toes in the water.
No.
They're diving head first into the AI pool
Making a splash.
with this fifth-generation computer system project.
That's right.
What exactly was their grand vision?
So Japan had always been a technological powerhouse, but they were tired of playing catch-up.
Oh?
They wanted to leapfrog the U.S.
Wow.
and become the world leader in computing.
Ambitious.
It was ambitious.
So they saw AI as the future
Yeah.
and were determined to be at the forefront
At the cutting edge.
of this revolution.
They wanted to define the future.
So they decided to bet big on AI,
They did.
even while the rest of the world was pulling back.
Yeah, they went all in.
Wow.
They called it the fifth generation
Yeah,
because they saw it as a fundamental shift from previous generations of computers.
Okay.
Their goal was to create a new breed of computers, specifically designed for knowledge processing.
Knowledge processing.
These weren't your typical number crunching machines.
Okay.
They wanted to build computers that could understand reason and learn,
Like humans.
just like humans.
That's a pretty audacious goal.
It was a huge goal.
How do they plan to pull that off?
Well, they put their faith in something called logic programming.
Logic programming.
Okay. They believed that by building computers optimized for logical operations, they could create machines that could process information in a more human-like way.
So instead of relying on brute force calculations, they were trying to imbue computers with the ability to think logically.
That was the idea.
Fascinating. How did they go about building these logic-powered supercomputers?
They formed an institute called ICIAT,
ICIAT.
the Institute for New Generation Computer Technology,
Okay.
and poured a massive amount of money and resources into the project.
Like how much are we talking?
They were talking about $1 billion.
$1 billion.
A truly significant investment.
They were all in.
They were committed.
So they had the money, the talent, and the determination.
They had it all.
Did their gamble pay off?
Well,
Were they making significant breakthroughs?
they definitely made progress on the hardware side.
Okay.
They built impressive parallel processing machines
Okay.
that could handle massive amounts of data.
So they had the horsepower.
Yeah, they had the hardware.
But what about the software?
The software.
Were they able to create programs that could actually think and reason?
That's where things got tricky.
Okay.
Despite their best efforts, the software side of the project didn't quite live up to the hype. They were able to create programs that could do things like translate languages
Okay.
and prove mathematical theorems.
Uh-huh.
But these weren't exactly groundbreaking achievements.
It sounds like they could build the machines,
Yeah,
but couldn't quite crack the code of artificial intelligence.
that's a good way to put it.
Yeah.
One of the biggest hurdles was the sheer complexity of developing truly intelligent software.
Yeah, I can imagine.
Even with powerful hardware designed for logic programming.
Right.
Creating programs that could understand and reason like humans
Yeah.
proved to be incredibly difficult.
So it's like they built a Ferrari,
Yeah,
but forgot to put an engine in it.
I like that analogy.
They had the hardware, but the software was lacking.
The software was the missing piece.
And to make matters worse,
Oh,
they also encountered another problem.
what's that?
The rapid advancement of microprocessor technology.
Oh, right.
While they were busy building their specialized logic machines,
Yeah.
the rest of the world was making huge strides
Yeah.
in conventional computing.
Things were moving fast.
So the technology they were banking on was becoming obsolete before they could even finish the project.
That's unfortunate timing.
It is.
By the time they had built their fifth generation computers, conventional microprocessors had become powerful enough
Oh, wow.
to handle many of the tasks their specialized machines were designed for.
So their grand vision was starting to unravel.
It was.
What about the software?
Yeah.
Was anything salvageable?
Not really.
And all that research and development?
They made some contributions to the field of logic programming.
Okay.
But for the most part,
Yeah.
the software they developed wasn't particularly groundbreaking. It didn't lead to any major breakthroughs in artificial intelligence.
So after a decade of intense effort.
Yeah, a lot of work.
And $1 billion spent.
A lot of money.
The fifth-generation computer system project ended.
Yeah.
With more of a whimper than a bang.
More of a fizzle.
What went wrong?
Well, there are several lessons to be learned from the FGCS project.
Okay.
One of the biggest takeaways is that hardware alone isn't enough to achieve true artificial intelligence.
Right.
You can build the most powerful computer in the world, but without the software to make it think, it's just a very expensive paperweight.
So we're back to that tension between hardware and software.
We are.
You can have a state-of-the-art kitchen,
right,
but still not know how to cook.
Exactly.
The FGCS project highlighted just how crucial software is.
It did.
In achieving artificial intelligence.
It's fundamental.
They had the hardware.
Yeah.
But they couldn't crack the code of intelligent software.
They couldn't figure out the software side of things.
And their over-reliance on logic programming also contributed to their downfall.
It did.
They put all their eggs in one basket.
In one basket.
And it turned out to be a dead end.
It happens.
But you have to admire their ambition.
I do.
It takes guts to swing for the fences like that.
It does.
Even if they strike out.
Even if it doesn't work out.
Their unwavering belief in the possibility of thinking machines is inspiring.
It is inspiring.
Even though they didn't succeed.
Yeah.
They pushed the boundaries of what was possible.
They did.
And inspired others to continue the quest.
To keep going.
For artificial intelligence.
Keep searching.
It's a cautionary tale.
Yeah.
But also a reminder that innovation often requires taking risks.
Absolutely.
Who knows, maybe someday someone will pick up where they left off.
It is possible.
And finally crack the code of true artificial intelligence.
Maybe they laid the groundwork for someone else's success.
I think that's a great place to pause for now.
Okay.
The FGCS project, despite its shortcomings, offers some profound insights into the nature of AI research.
It does.
Which we can dig into further.
Sounds good to me.
All right, so before the break, we were talking about Japan's fifth-generation computer system project.
Yeah, that ambitious endeavor.
That ultimately fell short of its goals.
Didn't quite hit the mark.
But you were saying there's still some valuable lessons to be learned from their experience.
Oh, absolutely. Even in failure, there are insights to be gained.
Okay.
And the FGCS project, despite its shortcomings, really highlights some crucial aspects of AI research.
Okay, so let's delve into those lessons.
All right, let's do it.
What can we learn from the FGCS experience that's applicable to the broader pursuit of artificial intelligence?
Well, one key takeaway is the importance of software.
Software.
Yeah, we often get caught up in the excitement of cutting-edge hardware.
Right.
You know, those super fast processors and massive supercomputers.
The bigger, the better.
Right. It's tempting to think that.
Yeah.
But the FGCS project showed us that software is the true bottleneck in AI development.
It's like having a world-class orchestra.
Okay.
But no sheet music for them to play.
Yeah.
The instruments are there.
Yeah.
But without the instructions.
Yeah.
The music can't happen.
Exactly. You can have all the processing power in the world, but without intelligent software to harness that power, you're not going to achieve true AI.
So the FGCS project was a bit of a wake-up call for the AI community.
Yeah, it was a reality check.
It shifted the focus from hardware to software.
Right.
And helped pave the way for the software-driven AI revolution we're seeing today.
It's a great example of how even failures can propel progress.
Yeah, sometimes you got to take a step back to move forward.
2 steps forward, 1 step back.
But the lessons from the FGCS go beyond just the importance of software.
Okay.
Their experience also offers valuable insights into managing hype and expectations.
Oh, the hype factor.
Right. We've seen how unrealistic expectations contributed to the AI winter.
We have.
How did this play out with the FGCS project?
Well, the FGCS was launched with tremendous fanfare.
Okay.
It was hailed as Japan's moonshot, a national effort to dominate the future of computing.
So the pressure to succeed must have been immense.
Well, it was enormous.
Yeah.
And that kind of pressure can easily lead to inflated expectations and overhyping a technology's capabilities.
And then when those expectations aren't met, it can backfire.
It can.
Leading to disillusionment and a loss of funding.
Exactly. It can create a backlash.
So it's a reminder that we need to temper our enthusiasm with realism.
A little bit of caution is always a good thing.
Yeah. It's great to be excited about the potential of AI.
Oh, for sure.
But we also need to be honest about the challenges involved.
Absolutely. We need to be realistic about the timeline
Yeah.
and the complexity of the problem.
The FGCS project reminds us
It does.
that achieving artificial intelligence is a long-term endeavor.
It's a marathon, not a sprint.
That requires patience, perseverance,
Yeah.
and a willingness to learn from our mistakes.
We're going to make mistakes along the way.
It's about taking the long view,
Right.
recognizing that progress is often incremental,
It's a step-by-step process.
and being prepared to adjust course along the way.
We need to be flexible and adaptable.
But even though the FGCS project fell short of its ambitious goals,
Yeah.
it laid some important groundwork for future AI advancements.
It did. They planted seeds.
Yeah, it's like they planted seeds.
That might not have bloomed immediately,
Right.
but their efforts enriched the soil.
For future generations of AI researchers.
I like that analogy.
Now, taking a step back and looking across these various chapters in AI history,
Okay.
from the Turing test to expert systems to the FGCS project,
A lot of ground covered.
what are some of the recurring themes you see emerging?
Well, one that stands out is this persistent quest to create thinking machines
Right from the very beginning.
from the very start.
It's this goal
Yeah.
that has captivated researchers
It has. It's a fundamental question.
and continues to drive the field forward.
Yeah, this desire to create something in our own image.
To create something that can reason, learn,
Yeah.
and perhaps even surpass our own intellectual abilities.
It's a powerful motivator.
But that raises some fundamental questions.
It does.
What does it actually mean for a machine to think?
That's a big one.
Can we even create something that surpasses our own intelligence
Yeah.
when we don't fully understand how our own minds work?
That's the paradox, isn't it?
It's a real head scratcher.
Those are big questions.
They are.
And they point to another recurring theme. This tension between brute force and true understanding.
Right. We've seen this play out time and time again.
We have.
From those early chess programs
Well,
to Japan's logic-powered computers.
right. Is true artificial intelligence simply a matter of throwing more processing power at the problem? Or does it require a deeper understanding of how intelligence actually works?
That's a debate that continues to this day,
It does.
especially with the emergence of machine learning and deep learning.
Those are game changers?
We have these incredibly powerful algorithms
Yeah.
that can learn from massive amounts of data.
They can devour data.
But we still don't fully understand how they work
It's a bit of a mystery.
or whether they're truly exhibiting intelligence.
It's like having a black box
Yeah.
that produces amazing results,
Uh-huh.
but we can't peek inside to see how it's doing it.
Right.
It's effective, but somewhat unsettling.
Yeah, a little bit creepy.
Which brings us to another important theme,
Okay.
the importance of managing hype and expectations.
All right, we talked about that earlier.
It did.
We've seen how inflated promises and unrealistic timelines can lead to disappointment and setbacks,
Like the AI winter,
like the AI winter.
which was partly triggered by the failure of machine translation to live up to its hype.
It's a crucial reminder to balance our enthusiasm with realism.
Yeah, we need to keep our feet on the ground.
We need to celebrate the progress we've made
For sure.
while acknowledging the significant challenges that lie ahead.
It's a balancing act.
Overhyping AI can actually hinder its progress
It can.
by setting unrealistic expectations
Right.
and leading to funding cuts when those expectations aren't met.
People get disillusioned.
So it's about walking that fine line between optimism and skepticism,
Yeah. Finding that middle ground.
celebrating the achievements
Absolutely.
while remaining grounded in the realities of the field.
We need to be both excited and cautious.
Okay, so we've covered a lot of ground in our deep dive into the history of AI.
We have.
We've seen how the field has evolved from early dreams of thinking machines to the mind-blowing capabilities of deep learning.
It's been quite a journey.
As we approach the present day, things really start to accelerate.
They do.
New technologies emerge that blur the lines
Yeah.
between science fiction and reality.
It's getting harder and harder to tell the difference.
We're talking about things like machine learning,
Yeah.
deep learning, and neural networks,
Real cutting edge.
technologies that are enabling computers
Right.
to perform tasks once considered the exclusive domain of humans.
Things we never thought possible.
We're seeing AI being used in self-driving cars, personalized medicine,
Yeah.
financial forecasting, and so much more.
It's everywhere.
It's a truly transformative technology,
It is.
and it's raising important questions about the future of humanity.
Big questions.
It's exciting, but also a bit daunting.
It is a bit of both.
But before we get too far ahead of ourselves,
Okay.
let's take a step back
All right.
and trace the path that led us to this point.
Back to the roots.
One of the most significant shifts in recent decades has been the rise of data-driven AI.
Data is king.
Data-driven AI. So instead of relying on handcrafted rules and logic, as in those early expert systems,
the old school approach,
we're now letting computers learn from massive amounts of data.
That's the new wave.
And this shift has been driven by two key factors.
Okay, what are they?
The explosion of digital data.
The data deluge.
And the increasing power of computers.
More power, more data.
We're generating more data than ever before.
We are, from our online activity, our smartphones, sensors, you name it.
It's everywhere.
And we now have the computing power to sift through all that data and extract meaningful insights.
It's like finding needles in a haystack.
Exactly. This confluence of factors has led to the rise of machine learning.
Machine learning.
A powerful set of techniques that enables computers to learn from data without being explicitly programmed.
So instead of telling the computer exactly what to do, we feed it a vast amount of data.
We give it the raw material.
And let it figure out the patterns and relationships on its own.
We let it loose.
So it's like we're providing the raw ingredients.
Yeah.
And the machine learning algorithms are the chefs.
Okay, I like that.
Creating something new and unexpected from those ingredients.
A culinary masterpiece of data.
And this approach has led to some incredible breakthroughs.
It has.
In areas like image recognition, speech recognition, and natural language processing.
Areas that were once considered beyond the reach of machines.
It's amazing how far we've come.
It really is. Progress has been exponential.
Machine learning has revolutionized these fields.
It has.
Allowing computers to perform tasks that were once thought to be exclusively human.
Things we thought only humans could do.
And in some cases, they're even surpassing human capabilities. For example, certain machine learning algorithms are now better than humans at detecting cancer in medical images.
That's incredible.
Or identifying fraudulent financial transactions.
They're catching things we miss.
That's both impressive and a little bit unnerving.
It is a bit of both.
It seems like we're entering a new era.
Yeah.
Where machines are starting to outperform humans.
In some areas.
In areas that were once considered our strengths.
It's a shift in the balance of power.
What are your thoughts on that?
Well, it's certainly a development that raises many important questions.
Yeah.
It's a time of rapid change.
It is. Things are moving fast.
And there's a lot of debate about what this means for the future of humanity.
Right.
Some people are excited about the potential of AI to solve some of the world's most pressing problems.
Like curing diseases.
Exactly.
Or ending poverty.
Those are big goals.
While others are concerned about the potential risks.
Yeah, there are risks too.
It's a complex issue with no easy answers.
It is. We need to be thoughtful about how we proceed.
But one thing is clear. AI is here to stay.
It's not going away.
And it's going to continue to shape our world in profound ways.
It's already having a huge impact.
Absolutely.
Yeah.
So how did we go from those early machine learning algorithms to the more recent mind-blowing capabilities of deep learning and neural networks?
That's a good question.
What's the story there?
Well, it's a story of going deeper, quite literally.
Okay.
Deep learning is a subset of machine learning that involves training artificial neural networks with multiple layers.
Hence the term deep.
Yeah, we're going deep.
Okay, neural networks. Now, those sound like something straight out of a science fiction movie.
They do sound a bit futuristic.
Can you break it down for us?
Sure.
What exactly are these neural networks?
Okay, so imagine a network of interconnected nodes.
Nodes?
Yeah, kind of like a vast web.
Okay.
These networks are loosely inspired by the structure of the human brain.
Oh, wow.
With each node performing a simple calculation.
Okay.
And the connections between nodes transmitting signals.
So it's like a network of mini brains.
It's a simplified way to think about it.
Okay.
But it captures the general idea. By adjusting the strength of the connections between those nodes, we can train these networks to perform specific tasks.
So we're essentially teaching computers to think.
Yeah, in a way.
By mimicking the structure of our own brains.
That's the inspiration.
That's incredible.
And what's remarkable about deep learning is that these networks can learn incredibly complex patterns and relationships.
Wow.
From vast amounts of data.
Even those that are too subtle or complex for humans to discern.
They can see things we can't.
And that's led to some pretty impressive results, right?
Oh, yeah.
We're seeing deep learning used in everything from self-driving cars to personalized medicine to creating realistic-sounding voices for virtual assistants.
They're getting really good at that.
It's a truly transformative technology.
It is.
And one of the key breakthroughs that enabled deep learning was the development of more powerful computing hardware.
Right.
Specifically, graphics processing units, or GPUs.
GPUs, those are the things that make video games look all fancy and realistic, right?
They are.
It turns out that GPUs are also incredibly good at performing the kinds of parallel computations needed for deep learning.
Interesting.
Their architecture, originally designed for rendering graphics, is also well-suited for processing the large data sets and complex calculations involved in training deep neural networks.
So it's like we repurposed gaming technology.
In a way.
To fuel the AI revolution.
It's one of those unexpected convergences of technology.
So we've thought.
And this has led to an explosion of research and development in deep learning.
Wow.
With breakthroughs happening at a pace that's hard to keep up with.
It's exciting, but also a little bit overwhelming.
It is a lot to take in.
We're venturing into uncharted territory.
We are.
And it feels like we're only just beginning to grasp the full implications of this technology.
We're still figuring it out.
Where do we go from here?
That's the big question, isn't it?
It is. It feels like we're at a turning point.
And it's one that we'll need to address thoughtfully and carefully.
Yeah.
This rapid progress in AI is raising all sorts of ethical and philosophical questions that we're only beginning to grapple with.
Questions about the potential for misuse.
Yeah.
The impact on jobs. And even the nature of consciousness itself.
Those are big ones.
Big question.
Exactly. These are big, challenging questions, and there are no easy answers.
Yeah. It's going to take a lot of thought and discussion.
But it's a conversation that we need to have as we continue to develop and deploy these powerful technologies.
Absolutely. So let's take some time to reflect on these questions.
Pause for a moment.
And then come back to explore these emerging challenges.
All right.
And what they mean for the future of AI. All right, so we're back, and before the break, we were getting into some pretty deep stuff.
Yeah, the philosophical side of AI.
Talking about deep learning, neural networks.
Yeah.
And how they're pushing the boundaries of AI.
It's amazing what we can do now.
In ways we never imagined.
Yeah, things are moving so fast.
And with that progress comes some serious ethical and philosophical questions.
It's not just about the technology anymore.
That we as a society need to address.
We need to think about the implications.
It feels like we're standing at a crossroads.
Yeah, a fork in the road.
The potential benefits of AI are immense.
They are.
But so are the potential risks.
There's a dark side, too.
How do we navigate this uncharted territory?
Carefully, that's for sure.
One of the biggest concerns is the potential for AI to be used for malicious purposes.
Right. It's a powerful tool.
Think about autonomous weapon systems.
Yeah.
That can make life or death decisions.
Without human oversight.
Without human intervention.
That's scary.
Or deepfakes that can be used to spread misinformation.
Oh, yeah.
And so discord.
They can be very convincing.
It's a stark reminder that any powerful technology can be used for good or evil.
It's a double-edged sword.
It's up to us to ensure that AI is developed and deployed responsibly.
We need to be proactive.
Absolutely. We need to establish clear ethical guidelines and regulations.
Yeah, we need some rules of the road.
For the development and use of AI.
Some guardrails.
It's not just about the technology itself.
Right.
But about the values and intentions of those who wield it.
It's about human responsibility.
Another concern that's often raised is the potential for AI to displace human workers.
Yeah. That's a big one.
What happens when machines can do our jobs faster?
More efficiently.
Cheaper and more efficiently.
It's a valid concern.
It's a legitimate concern.
And one that we need to address proactively.
What can we do?
Well, we need to think about how we can adapt to a future where automation plays an increasingly important role in the workforce.
Maybe we need to rethink our education systems.
Yeah.
Focus on developing skills that are uniquely human.
What makes us human?
Skills that machines can't easily replicate.
Things that AI can't do.
Things like creativity, critical thinking.
Yeah, those are important.
And emotional intelligence.
Those are hard to program.
I think that's crucial.
It is.
We need to foster those qualities that make us human.
The things that set us apart.
The things that machines, even the most advanced AI, can't replicate.
We need to emphasize those strengths.
We need to equip people with the tools and knowledge.
Yeah, give them the skills they need.
To thrive in a future.
To adapt and succeed.
Where human-machine collaboration is the norm.
It's not about replacing humans.
Right.
It's about working together.
It's not about humans versus machines,
Right.
but about humans and machines
Yeah.
working together to achieve common goals.
We need to find that synergy.
Exactly. It's about harnessing the power of AI
To augment our own abilities.
to solve problems,
To make things better.
to improve our lives, and to create a better future for everyone.
That's the ultimate goal.
Well said. So we've covered a lot of ground in our deep dive into the history of AI.
We have from the beginning to now.
We've seen how the field has evolved
Yeah.
from early dreams of thinking machines
Those early pioneers.
to the mind-blowing capabilities of deep learning.
It's been quite a ride.
As we wrap things up,
Okay.
what are some of the key takeaways
Yeah.
you want our listeners to remember?
Well, I think one of the most important lessons is that AI is not a monolithic entity.
Okay.
It's not a single technology or a singular path.
Right.
It's a constantly evolving field
Always changing.
with a rich and complex history.
We've seen how hype can lead to disappointment,
Yeah, those boom and bust cycles.
how failures can spark innovation,
Sometimes you got to stumble to find the right path.
and how the quest for artificial intelligence
Yeah.
is ultimately a reflection of our own humanity.
It's a mirror to ourselves.
We've seen how the pursuit of AI has pushed the boundaries
It has.
of computer science mathematics,
Yeah.
and even our understanding of our own minds.
It makes us question what it means to be human.
And we've seen how the story of AI is ultimately a story about us,
It is.
about our dreams, our fears,
Yeah, our hopes and anxieties.
and our endless fascination with the unknown.
We're always pushing the limits.
So as we move forward into this uncharted territory,
Yeah.
let's remember the lessons of the past.
Let's learn from our mistakes.
Let's approach AI with a sense of wonder,
Yeah.
but also with caution and a commitment to responsible development.
We need to be careful.
Let's embrace the possibility,
The potential is huge.
but let's also be mindful of the potential risks.
We can't ignore the downsides.
And let's work together to ensure that AI is used to create a future
Yeah.
that benefits all of humanity.
That's the goal.
Well said. So as we conclude this deep dive, we want to leave you with one final thought-provoking question.
Okay.
What role do you believe AI will play in shaping the future?
Yeah, think about that.
What are your hopes and concerns?
What kind of future do you want to see?
What steps can we take individually and collectively
What can we do?
to ensure that AI is used for good?
It's up to us.
We encourage you to ponder these questions,
Keep thinking.
to engage in thoughtful discussion,
Talk to each other.
and to stay informed about this rapidly evolving field.
It's changing every day.
The future of AI is not predetermined.
We have a choice.
It's a future that we are all creating together.
We're all in this together.
Thanks for joining us on this journey through the history of AI.
It's been a pleasure.
We hope you've gained a deeper understanding
Yeah.
of this fascinating and complex field.
There's always more to learn.
And we hope you'll continue to explore
Yeah.
the endless possibilities
The future is full of possibilities.
of artificial intelligence.
It's an exciting time.
Until next time, keep those brains buzzing
Keep learning.
and stay curious.
And remember, the future is what we make it.